Now, take a look at this situation. Two airplanes are moving towards each other. If they continue to fly in the same direction along the same path, they are certain to collide at a certain point. What will be the point of collision of the two planes? This can be found by representing the situation on a coordinate system. Let the original position of the first plane be represented at A, x1, y1, and that of the second be at B, x2, y2. The position of a point of collision can be determined by finding its coordinates at point P. Suppose Px, y is the point where the planes collide. Let Px, y divide the paths between two planes in the ratio m1:m2 such that PA divided by PB is equal to m1 by m2. Let us represent this as equation 1. Draw lines AR, PS, BT perpendicular to x-axis and lines AQ and PC parallel to x-axis. We observe that triangle PAQ is congruent to triangle BPC. Why are the two triangles equal? By AA criterion, if two angles of one triangle are correspondingly equal to two angles of the other, then the two triangles are congruent. Therefore, the ratio of the lengths of the sides is also equal. PA by BP is equal to AQ by PC, which is equal to PQ by BC. Let us represent this as equation 1. Here in the coordinate system, we find AQ is equal to RS, which is equal to OS minus OR, that is equal to X minus X1. PC is equal to ST, which is equal to OT minus OS, that is equal to X2 minus X. PQ is equal to PS minus QS, which is equal to PS minus AR, that is equal to Y minus Y1. BC is equal to BT minus CT, that is equal to BT minus PS, that is equal to Y2 minus Y. Substituting in equation 1, we get M1 divided by M2 is equal to X minus X1 divided by X2 minus X, which is equal to Y minus Y1 divided by Y2 minus Y. Let us represent this as equation 2. M1 by M2 is equal to X minus X1 divided by X2 minus X, and M1 by M2 is equal to Y minus Y1 divided by Y2 minus Y. On simplification, we get X is equal to M1 X2 plus M2 X1 divided by M1 plus M2. Similarly, Y is equal to M1 Y2 plus M2 Y1 divided by M1 plus M2. So, Px, y is equal to M1 X2 plus M2 X1 divided by M1 plus M2, M1 Y2 plus M2 Y1 divided by M1 plus M2 is the point of collision between the planes. This is called the section formula. Now, let us solve some real-life problems using section formula. In a football match, if the goalkeeper and the defender were positioned at -2, -2 and 2, -4 respectively, find the position of the striker at P who kicks a goal if distance between him and the goalkeeper is 3 by 7 times the distance between the goalkeeper and the defender. Let us represent the positions of the defender and goalkeeper in the coordinate system at points -2, -2, 2, -4 represented at A and B. From the coordinate system, we observe that the distance between the striker and goalkeeper is equal to the difference in the distance between the defender and the goalkeeper and the distance between the defender and the striker. That is, BP is equal to AB minus AP. So, AP by PB is equal to 3AB by 7 divided by 4AB by 7, which is equal to 3 by 4. That is, P divides AB in the ratio 3:4. According to section formula, coordinates of the point which divides the line joining the 2 points in the ratio m1 is to m2 internally is m1 x2 plus m2 x1 divided by m1 plus m2. m1 y2 plus m2 y1 divided by m1 plus m2. Applying section formula and simplifying, we get coordinate of p x, y is equal to p minus 2 by 7, minus 20 by 7. The striker is positioned at point minus 2 by 7, minus 20 by 7 between the defender and the goalkeeper. Now, let us apply section formula to solve some real-life examples. In a football match, if the goalkeeper and the defender were positioned at minus 2, minus 2 and 2, minus 4 respectively, find the position of the striker at P who kicks a goal if distance between him and the goalkeeper is 3 by 7 times the distance between the goalkeeper and the defender. To solve this, let us represent these points on the coordinate system. Here, the position of the goalkeeper is at A equaling 8, minus 9 and the position of the defender is at B equals 2, 1. Let the ball cross the path between goalkeeper and defender at P x, y. Suppose the line 2x plus 3y minus 5 equals 0 divides the path joining A 8, minus 9 and B 2, 1 in the ratio k is to 1 at P. According to section formula, coordinates of the point which divides the line joining the 2 points in the ratio m is to n internally is m1 x2 plus m2 x1 divided by m1 plus m2, m1 y2 plus m2 y1 divided by m1 plus m2. From section formula, we get p x, y is equal to p 2k plus 8 divided by k plus 1, k minus 9 divided by k plus 1, equation 1, which lies on 2x plus 3y minus 5 equals 0. Substituting the coordinates of p as x, y coordinates in the equation, we get 2 into 2k plus 8 divided by k plus 1 plus 3 into k minus 9 divided by k plus 1 minus 5 is equal to 0. On further simplifying and solving, we get value of k is equal to 16 by 2, which is equal to 8. So, the required ratio is 8:1. Now, substituting k equals 8 in equation 1 and simplifying, we get p x, y is equal to p into 8 by 3, minus 1 by 9. So, if the striker makes a goal by kicking the ball across the path of goalkeeper and defender at point P 8 by 3, minus 1 by 9, which divides the path in the ratio 8:1. How would you determine the coordinates of the midpoint of any side and the centroid of a triangle? Suppose points 5, minus 1, minus 3, minus 2 and minus 1, 8 are the vertices of a triangle. Find the coordinates of the centroid of a triangle. AD is the median through the vertex A of triangle ABC. So, D is the midpoint of side BC. D divides the line joining B, minus 3, minus 2 and C, minus 1, 8 in the ratio 1:1. We know from section formula coordinates of the point which divides the line joining the 2 points internally is m1 x2 plus m2 x1 divided by m1 plus m2, m1 y2 plus m2 y1 divided by m1 plus m2. Substituting the known values in the section formula and simplifying, we get coordinates of D is equal to minus 2, 3, which is the midpoint of the line segment BC. G is the centroid which lies on the median AD and divides the median in the ratio 2:1. Applying section formula and substituting the known values of coordinates of A and D and simplifying, we get coordinates of G as 1 by 3, 5 by 3. Therefore, the coordinates of the centroid of triangle is 1 by 3, 5 by 3. Let us summarize some important conclusions from the above problems. In the above problem, we observe that if Px, y divides the line segment internally in the ratio 1:1, then from section formula we get Px, y is equal to x1 plus x2 divided by 2, y1 plus y2 divided by 2, which are the coordinates of the midpoint of a line. This is called midpoint formula. If x1, y1, x2, y2, x3, y3 are the vertices of a triangle, centroid G lies on the median and divides it in the ratio 2:1, then from section formula we get Gx, y is equal to x1 plus x2 plus x3 divided by 3, y1 plus y2 plus y3 divided by 3, which are the coordinates of the centroid of a triangle. Now, let us apply section formula and distance formula that we learned to determine area of triangle. We have learned to determine area of triangle in our earlier classes. Now, let us do a quick recap on this. Suppose ABC is a triangle with base which is equal to 5 centimeters and altitude equaling 8 centimeters, then what is its area? When base and altitude is given, area of triangle can be found using the basic formula that area of triangle is equal to half into base into height. ABC is a triangle with given sides A, B, C respectively. Can you determine the area of triangle when length of each side is given? Here, area can be computed using Heron's formula. Area of triangle is equal to square root of S into S minus A, S minus B, S minus C, where S is equal to A plus B plus C divided by 2. ABC is a triangle with vertices A, x1, x2, B, x2, y2, and C, x3, y3. How would you determine the area of triangle when coordinates of its vertices are given? To find this, draw AP, BQ, and CR perpendicular to the x-axis. From figure, area of triangle ABC is equal to area of trapezium ABQP plus area of trapezium APRC minus area of trapezium BQRC. We know that area of trapezium is equal to half into sum of parallel sides into distance between them. Area of ABC is equal to half BQ plus AP into QP plus half AP plus CR into PR minus half BQ plus CR into QR, which is equal to half Y2 plus Y1 x1 minus x2 plus half y1 plus y3 into x3 minus x1 minus half into y2 plus y3 into x3 minus x2. That is equal to half x into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. What do you conclude from this? When the coordinates of the vertices of a triangle are x1, y1, x2, y2 and x3, y3, then the area of triangle is given by half into x1, y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. What happens when the area of triangle reduces to 0? The 3 points will be collinear. We know area of triangle is equal to half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. When area is equal to 0, then x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 is equal to 0. So, the condition for 3 points to be collinear is area formed by the 3 coordinates is 0 or x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 is equal to 0. Class 10 students of a school have been allotted a rectangular plot of land for gardening. There is a triangular grassy lawn in the plot. Compute the areas of triangle formed with respect to its origins. To find the area of triangle PQR with A as origin and taking AD and AB as coordinate axis, then the vertices of triangle are P 4, 6, Q 3, 2 and R 6, 5. We know the area of triangle is equal to half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Substituting the known values and simplifying, we get area of triangle PQR is equal to 9/2 square units. To find the area of triangle PQR with C as origin and taking CB and CD as coordinate axis, then the vertices of triangle are P 12, 2, Q 13, 6 and R 10, 3. Substituting the known values in the formula of area of triangle and simplifying, we get area of triangle PQR as 9/2 square units. What do you conclude from this? From this, we conclude that in a coordinate system, the areas of triangles will be the same irrespective of their origins. Now, let us do some more problems using formula for areas of triangles given coordinates of its vertices. Find the area of quadrilateral whose vertices taken in order are -4, -2, -3, -5, 3, -2 and 2, 3. To find this, let us join AC to get two triangles ABC and ADC. Coordinates A -4, -2, B -3, -5, C 3, -2 form triangle ABC. We know area of triangle is equal to half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Now, tabulating the coordinates and cross-multiplying, we get area of triangle ABC is equal to 21/2 square units. Similarly, coordinates A -4, -2, D 2, 3, C 3, -2 form triangle ACD. Now tabulating the coordinates and cross-multiplying, we get area of triangle ACD is equal to 35/2 square units. Area of quadrilateral ABCD is equal to area of triangle ABC plus area of triangle ACD. Substituting the computed values of areas in the above equation, we get area of quadrilateral ABCD is equal to 28 square units.